A pleasant morning to the young and enthusiastic learners. I'm Dr. Shobha, Principal, Associate Professor and Head of the Department of Corporate Secretaryship, KCS Kasinada College of Arts and Science, here to present on regression. So when it comes to regression, usually there are situations where there are two equations that are given, and that becomes difficult from the student's point of view to solve. So it is nothing but mere solution given for two equations. They've given in this question the mean values of x and y are to be found out and their correlation coefficient. So we have to find x bar, y bar and r. They've given us the standard deviation of x equal to 6. Then there's an equation and another equation. So two equations given to us. So while solving these two equations, what we have to do is we have to try and cancel either the x values or the y values. So now to make it simple, cancelling the x becomes easy because if I multiply 12x by 5, I will get 60x and it will be easy to cancel. So now I have multiplied the first equation by 5. So 12x into 5 is 60x, 15y into 5 is 75y, 99 into 5 is 495. So now I get the equation, the first equation is transformed by multiplying it by 5. I get it as 60x minus 75y plus 495 equal to 0. My second equation is as it is 60x minus 27y minus 0 is equal to 321. Now to cancel this x value, I have 60x and if I subtract 60x, it will get cancelled. So I am changing the signs of the second equation. So this plus becomes minus. Here it is minus 27y, I change it to plus. Minus 0, I change it to plus. And there is plus 321 which I change it to minus. Now this 60x minus 60x becomes 0 and I have minus 75y plus 27y which gives me minus 48y. Then I have 495 plus 0 which is 495 and a 0 minus 321 which is minus 321. Now keeping this 48y in my left hand side, I move the other terms to the other side. So when I take 495 to the other side, it is plus over here, so it goes to the other side, becomes minus. So it is minus 48y is equal to minus 321 minus 495. Now further solving, minus 48y is equal to minus 816. Now cancelling this minus and minus, I have y is equal to 816 by 48, y is equal to 17. And whatever value I get for y, that becomes the value of y bar, and so y bar is also 17. That is required to be found in the question. Now going to substitute the value of y as 17 in my equation. 12x minus 15y. So 15 into 17 plus 99 equal to 0. 12x minus 15 into 17 is 255 plus 99 equal to 0. 12x minus 156 is equal to 0. Taking the 156 to the other side, it was minus here, it comes here, it becomes plus. So 12x is equal to 156. X is equal to 156 divided by 12 because 12 was multiplied here. Taking it to the other side, you divide it. So x is equal to 13. Whatever be the value of x is the value of x bar. So x bar is equal to 13. So now we have the value of x bar as 13 and the value of y bar as 17. Now since I know that solving the first equation with the assumption of y on x, I get the answer. Since I know, I have picked it this way. But from your end, if you do not know, you would be taking this as x on y. But I will tell you the reason why and how it is done. So now, taking the first equation as y on x. So I've taken 12x minus 15y plus 99 equal to 0. So now since it is y on x, I keep y on one side and take all the other values to the other side. So minus 15y is equal to 12x, which was plus, is taken the other side, minus 12x. 99, which is also plus, is taken the other side, so it is minus 99. So now all these are in minus, so you can easily remove the signs and make them all plus. So once this is done, further y is equal to 12x plus 99 by 15. Whatever value is attached to x, that becomes byx. So it is 12 by 15, that is byx. Byx is 0.8. Now, the second equation I have to assume now as x on y. So, 60x minus 27y plus 0 is equal to 321. This is x on y. So, I am keeping x on one side. So, 60x is equal to this minus 27y is taken to the other side. It becomes plus, and the 321 is already there. So, now 60x is equal to 27y plus 321. Now x is equal to 27y plus 321 by 60. So whatever value is attached to this y becomes bxy. So it is 27 by 60. So bxy is 0.45. We already got byx. Now we got bxy. For the correlation coefficient, we have to multiply these two regression coefficients and find the root. And so sigma bxy into sigma byx, root of the whole thing. So 0.45 into 0.8, root of the whole thing. So r is root of 0.36. So when I take the root, I get r is equal to 0.6. And always the r value has to be between plus 1 and minus 1. It should not exceed 1. So since my r is 0.6, my assumption is right. So I go back to what we have done. So a rewinding. So when you go back, see, I took the first equation as y on x, and I took my second equation as x on y, and I arrived at r as 0.6. So if your value r is more than 1, then we should reverse the assumption and redo the question right from the equations. So if this r value was more than 1, then I would have taken the first equation as x on y and the second equation as y on x, and I would have done the solution and found bxy and byx again. But since my r is less than 1, my correlation coefficient is correct. So I can proceed further. Byx is equal to r standard deviation of y by standard deviation of x. Byx we just found out as 0.8 equal to r, also we found out 0.6. Standard deviation of y, standard deviation of x is given in the question. So we have substituted the three values and we are trying to find the value of standard deviation of y. So cross multiplying 0.8 into 6 is equal to 0.6 into standard deviation of y. So 4.8 is equal to 0.6 into standard deviation of y. Standard deviation of y is multiplied by 0.6. So if I take this 0.6 to the other side, I will have to divide. So standard deviation of y is equal to 4.8 divided by 0.6. So on dividing, I get the standard deviation of y value to be 8. So this is how you solve the two regression equations. So it is very simple. It is only based on our assumption of the two equations. If our assumption is right, our r will be right. If not, we have to redo the assumption and find the correct r. And once r is correct, we can find the other values. Thank you and happy learning.